All right, here we go. Section 9 of Chapter 5 is the last section of this chapter. Yay! I like to wrap one up and start a fresh one. Today we're going to write polynomial functions. And now we've done that with 2 points, and you wrote a line, 3 points, and we drew a parabola. And now if you have 4 points will give you the graph of a cubic function. All right, and so the cubic function, remember, has an exponent of 3. So what we're going to do, let's just jump right into it. I'm going to give you a graph. And now in your problems, I might give you the picture of the graph, or I might give you the points. Because remember, we said you have to have 4 points. If you have 4 points on the graph, then we can come up with the function of the graph. So in this case, we've got the points, and now we've got 3 intercepts, 3 x-intercepts. Negative 2, 0 is one of them. Negative 1, 0, and 1, 0. And I've given you 1 point on the graph, and that is 0, 6. So you'll have problems like this 2 different ways. Either I'll give you the graph that looks like this, and I'll say, you find the points, or I will find the points and give you a list of points, and then you'll need to come up with the cubic function. So you're supposed to write the cubic function. Now, if you'll remember, the cubic function, the form is y equals a of x minus your intercepts, and then times x minus something times x minus something, right? Okay, just like the parabola, except we're adding another intercept. So we're using the same type of format. So now what you're going to need to do is you're going to put in your intercepts. Now these are the ones that 0 is in the y value, because it's not going to go up or down. It's going to stay on the x-axis. So you're going to put in the negative 2. So negative of a negative is a plus 2. You're going to put in this negative 1, so make that plus 1. And you're going to put in this 1, so that's minus 1. And you say to me, well, what good is this 0, 6? Ha, ha, ha. That's how we're going to get our a value. All right, so what we're going to do is you're going to put in 0, 6 for the y, the x and the y, and that's going to give you your a, which is the unknown right now, and then we'll put it back into this format. So your y is 6, and your x's are all 0. So it's going to be 6 times 2 times 1 times negative 1. Whoop, 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 whoop. All right, so 2 times 1 is 1. Negative 1 times 2 is negative 2. So you have 6 equals negative 2a. Divide by the negative 2. So a gives you negative 3. Okay, so now you have all your parts and pieces. Now all you have to do is make it look like a cubic function. So put your a back into this form here that you started. So y equals negative 3 times x plus 2 times x plus 1 times x minus 1. All right, and now essentially you're finished. You have all the parts, but now we simply need to make it look like a cubic function. So we're going to go through, and I'm recognizing x plus 1, x minus 1. So I'm going to do this one first. And so I'm going to say that's x squared minus 1, because remember, if you've got an x plus 1, x minus 1, your middle terms are going to drop out. All right, because you've got negative x, positive x, that drops out. So don't lose the rest of it. Now you're going to use FOIL to multiply these two. Excuse me, x times x squared is x cubed. X times negative 1 is negative x. X times, oh, we already did that. Now 2 times x squared is plus 2x squared. And 2 times negative 1 is negative 2. And now you're going to multiply all that by negative 3. And I'm going to do this in one step, so hopefully it doesn't mess you up. What I'm going to do is I'm going to multiply through by the negative 3, and I'm going to put them into order. All right? So first I'm going to take my x cubed and multiply by negative 3. So y equals negative 3x cubed. And then I'm going to bring in the x squared over and multiply it by negative 3. So minus 6x squared. And don't lose your x term is next. Negative times a negative is a positive 3x. And then the last term is 2. Negative times a negative is plus 6. So this is really and truly your final answer, because now you have it in a cubic function from greatest degree to least degree. All right, so yeah, the hardest part of that is just making sure you do all of the steps. It's all stuff you've done before, all right? So that's how you write a cubic function given 4 points or a graph, all right? So did you notice that the points that I chose are the points where the x-axis is crossed? So it's those 3 points, and then I'll have to give you another point so that you have 4 points so that you can form a cubic function. All right. The next thing, so that's not so hard. The next thing is kind of fun, actually, because I love patterns. The next thing is finite differences. Finite differences are the differences of the consecutive y values of a function. All right, so that sounds all confusing. Let me break it down, and let's look at an example, and then it will make all sorts of sense. So the consecutive y values, so we just choose values to put into your function. And so it makes sense to just start with 1 because that's going to be easiest. 1, 2, 3, 4, 5. So if I have a function and I put in 1, 2, 3, and 4, and I get out, when I put those numbers into the function, I get out a 1, a 4, a 9, and a 16. If I put those values in and get these values out, what's going to happen is this. The finite differences are the differences between their values. So in this case, I want to take the 4 minus 1. So the difference here is 3. Hang with me just a minute. Just follow. It'll make sense in just a minute. Take the 9 minus 4, and that difference is 5. And then take the 16 minus 9. Always start with the one on your right and subtract the one on the left. 16 minus 9, and that gives you 7. Okay? And you're saying, what on earth are you doing? Stick with me. Hang on just a minute. Do that again. Excuse me. 5 minus 3 is 2. 7 minus 5 now is also 2. When you get to where the numbers are the same, where the differences are all the same, that's how you know this function excuse me, is going to have a degree of 1, 2, because this is the first order differences, and this is the second order differences. Okay, so first order differences, second order differences. All right, once you get all that down, go ahead and pause and make sure you get those steps down, and we'll do one together so that you can see what on earth are you talking about. Once you get it, it's really fun and cool. So pause and get that, and I'm going to give you one. All right, we're going to do the function of okay, so did you get all of that other down? What I want you to do is this. I want you to, once I give you the instructions, I want you to pause it, and I want to do it because we're not going to spend all the time. I'm not going to do all, I've already worked it out. I want you to do it. So what I want you to do is this. I want you to take the function of 1 and the function, we're going to go all the way up to 6. All right? Oh, and I'm going to have to write smaller. Okay, so here's what I want you to do when you pause. I want you to pause, and I want you to come up with how much, if I put in 1 for this function, what answer am I going to get? And I'll show you with 1 just to remind you, and then I want you to do all 6, and then I want you to come back, okay? So the function of 1, you're going to put 1 cubed is 1 times 1 times 1, so that's 1. All right, and then you're going to take, where did all my markers go? All right, so that's 1 minus 4 times 1 squared is 4, and then minus 1, and then plus 1. And so that value, if you work it out, is going to be -3. All right, and I want you to do that for 1 through 6. Pause, go. Okay, did you do it? Don't you be cheating. All right. So after you worked them out, and I worked them all out already, so make sure that I got them right. Oh my goodness, I hate it when I mess up. Okay, so if you put in 2, you should have gotten out -9. If you put in 3, you should have gotten -11. 4 would have come back to -3. 5 would have been 21. 6 would have been 67. All right, so now these are the values at your consecutive y values. These are the values for the function. So this isn't an order differences. This is just the y values. Once you get the starting y values, then you're going to start finding your differences. This is where the cool pattern thing comes in. So you're going to subtract. If you think you know what you're doing, pause and come back. So now be careful with your negatives. This is tricky because you're going to take -9 minus a -3. So that's actually going to be -6. Yes, oh boy. All right. And then -11 minus 9 gives you -2. -3 minus a -11 should give you a +8. 21 minus a -23 should give you 24. I'm checking to make sure I'm getting them right because, oh boy. And then 67 minus 21 should give you 46. And so this is your first order differences. Now, let me pause and tell you what you're proving is you're trying to prove that this is a third degree polynomial. All right. So if we've done all of our computation correctly, by the time we get to the third order difference, so this is the first order differences. By the time you get to the third order differences, your differences should all be consistent. Pretty cool, huh? All right. So do the second order differences. -2 minus a -6 should give you a +4. 8 minus a -2 should be 10. 24 minus 8 will be 16. 46 minus 24 is 22. And that's your second order differences. We weren't expecting them to be the same yet. This is where we expect them to be the same. So if we did everything correctly, they'll be the same because we happen to know that this is a third order difference. So 10 minus 4 is 6. 16 minus 10 is 6. And 22 minus 16 is 6. So all of the differences at the third order are consistent. They're the same and they're not 0. So we have proved that this is a third order polynomial. All right. So once you get that, it's like, oh, that's really cool, but getting it is a little bit tricky. So go back and watch again and see where I got the numbers. Do another one, choose one from, it's like page 394, 393, 394 in there, those couple of pages. Do a couple and check it out. So, because what I'm going to do now is move one step further and make it just a little bit trickier. All right? Because what we're going to do is this. We're going to use those finite differences to find a polynomial function. So if we know the polynomial function, we can prove that, yep, it's a third order. But what if we don't have that proof? All right. So what we're going to do is this. We can prove that let's see, use finite differences to find a polynomial function that fits this data. All right. So what we've got is we've got the numbers 1, 3, 6, 10, 15, and 21 all squished in there. So let's just figure out the first order differences. 3 minus 1 is 2. 6 minus 3 is 3. 10 minus 6 is 4. 15 minus 10 is 5. 21 minus 5 is 6. So there's our first order differences. Ooh, this looks like we're going to be close. 3 minus 2 is 1. 4 minus 3 is 1. 5 minus 4 is 1. 6 minus 5 is 1. So this is just a second order. This is just a quadratic formula with an exponent of 2. So here's what we can do from here. Now, if it's more than just 2, it's going to be really tricky and difficult, and I'm not going to make you do them by hand. You would actually plug these numbers into a calculator, and you could find out an equation. But I'm going to show you how to do that with just 2 without your calculator. Here you go. Woohoo! Very fun. Okay. You know, if it's a second degree polynomial, you've got ax squared plus bx plus c is your basic formula. So what we're going to do is this. We're going to come up with three equations with 3 unknowns, and we're going to be able to figure out what our a, b, and c are, and that'll be our equation. So we're going to start off with if we've got, remember this was the function at 1. So if our if our x is 1, so that means we've got a times 1 plus b times 1 plus c equals, there's our answer. So this is our answer. So we're going to have something equals 3, and we're going to have something equals 6. Okay, am I confusing you yet? Those are going to be our 3 equations. Okay, so the first one is just when f is 1, when your function is 1. Here's when your function is 2. So if your function is 2, here we go. So a times x squared, so 2 squared is 4, so 4 times a. And we're going to have b times 2, and then c doesn't get changed, plus c. And then this is for the function at 3. So a times 3 squared is 9. B times 3 is plus 3b plus c. Now this looks like something that you have solved before, right? So you can use addition and solve these. Let's just do it really quick. Are you ready? Here we go. If you think you got it, go ahead and pause it, and then you can just fast forward and see if yours matches mine. Okay, what I'm going to do is I'm going to combine the first 2. A plus b plus c equals 1, and negative 4a minus 2b minus c equals negative 3. Ooh, you know what? It would have been better to make this one negative so I didn't have to deal with negatives, but that's okay. Negative 3a minus b equals negative 2. And then let's combine the first one and the last one. And actually, I'm just going to do it right here. And I'm going to say minus a minus b minus c equals negative 1. So I get 8a plus 2b equals 5. And now, if I take this one times 2, my b's will cancel. So let's do that. Negative 6a minus 2b equals, we took it times 2, so negative 4. So now we've got 2a equals 1. So a equals 1/2. We're 1/3 there. All right. So then put your a equals 1/2 back into, you know what, if we put it into this one right here, let's do that. So half of 8 is 4 plus 2b equals 5. Then we can solve for b. So let's subtract 4. 2b equals 1. Oh, looky there. Huh. B is 1/2 too. Let me make sure that I got that correct because that would be a shame. That seems pretty crazy. Oh, but it is. Yay. Whew, I hate it when I make a mistake. So now b also equals 1/2. So a equals 1/2, b equals 1/2. So let's put it back into this one is going to be the easiest one. So a is 1/2 plus b is 1/2 plus c equals 1. Oh, 1/2 plus 1/2 is 1. So minus 1, so c equals 0. Ha! So, are you following me? Here we go. So now we're going to put a, b, and c back into this original equation. So a is 1/2. Let me use a different color marker and maybe that'll help you to see it. So a is 1/2, so 1/2 x squared plus b is 1/2 plus 1/2 x plus 0 is what we're looking for. So now what we can do is combine that, and we can say this is 1/2 x 1/2 plus 1/2, 1/2 x plus 1. Is that right? Oh dear, what did I do? Oh yeah, 1/2 x plus 1. There we go. If you wanted to leave it, or if you wanted to leave it 1/2 x squared plus 1/2 x, that's okay too. Either one of those is fine. All right. Whoo! I think I only gave you like 2 or 3 of those that have that big old long thing. All right. The rest are just making sure you understand finite differences and being able to write a polynomial function from your 4 points. All right. Have fun. See you soon.